Okay, so 6.2 practice. Now we're going to apply the concepts to numbers. It says in exercise 1 and 2, perpendicular bisectors. So that's important because now we're looking at perpendicular bisectors. Intersect at point G and are shown below. Find the indicated measure. So it wants us to find the length of BG. So just identifying what that is right here. Okay, so looking at what they gave us, perpendicular bisectors. So that is lines like right here. That's a perpendicular bisector. This is, and this is. Okay, so then we have our circumcenter right here. And that circumcenter is equidistant to all the vertices. So this blue is equal to this blue and this blue. These are all the same length. Okay, so it just wants us to find the length of BG. It shows us that AG is 9, and that's going to be the same length as BG. So BG equals 9. Okay, and number 2, same idea. This one looks a little bit different. They had to draw the lines like outside of the triangle. Let's see. So let me just highlight the perpendicular bisectors. Okay. And then I'll highlight the lines from the vertices. Alright. So all the blues are going to be the same length. And then it says it wants to find the length of GA, so this length here. Well, it says that GC is 11, so GA must also be 11. Okay, now we get to a real life example. It says you and 2 friends plan to walk your dogs together. You want a meeting place to be the same distance from each person's residence. Explain how you can use the diagram to locate the meeting place. Okay, well, let's draw a triangle then. Let's connect our dots to make a triangle. You can use your ID to make a straight edge if you need to. Okay, there's our triangle. So we need a spot that's equidistant from each corner, and that would be the circumcenter. And the circumcenter is where the perpendicular bisectors meet. Perpendicular bisectors meet. So if we draw so identify maybe the midpoint, just kind of eyeball it on each segment. Okay, and then just draw. You can kind of use the roads, actually. I didn't even realize that. You can use the roads to draw your perpendiculars. Or wait, that wouldn't be quite right. I guess it would be more like this. Trying to get a 90-degree angle here. It's not going to be perfect. Oh well. Okay, so I think it's about right here. So there's the circumcenter. So I tried my best to make a 90-degree angle here, 90-degree angle here, and then 90-degree angle here. And then I made a big dot for the circumcenter, and this should be the same distance from each of these points. So this should be the same length as this. Obviously there's probably some human error in there, but that's the idea. Okay, and number 4 is the same type of problem, same exact thing. We're finding the circumcenter. So I'm going to connect my dots to make a triangle. Okay, just eyeball it, make a midpoint on each segment. and then draw a perpendicular bisector. Okay, and it looks like it meets right about here. And then this should be the same distance to each of the corners. So this should be the same length as this, and this should be the same length as this. Okay. And now we're moving on to in-center, where we have angle bisectors. So for 5 and 6, it says now we have angle bisectors of the triangle. They intersect at point P. Find the indicated measure. Okay, so we're trying to find PB in this one, so this length here. I'm just identifying what we have. Angle bisectors, I'm going to make orange. Here's an angle bisector, here's one, and here's one. Then this right here would be the in-center. And then this in-center is equidistant from the sides. Okay, so it wants just the length of PB right here. It shows that this is 9, so PB must be 9 as well. How's coloring practice going? It's going good. Okay. And the next one. Next one looks a little bit more complicated. Same idea, it's just the lines are a little bit less clear. But I'm going to first start by highlighting my angle bisectors, the one that bisect the angles. Then I can look at the lines that go from that in-center to the sides. Height. Then HP. Okay, the length of HP is what they're looking for. It looks like KP is 15, so then HP would also be 15. Okay, the next one, where should he? I'm going to try to sketch it out. I'm going to just do one of these graphing ones just to see how it turns out. Let's see. Just draw a coordinate plane. A is at 0, 0. B is at 0, 8.
Are we supposed to do this with you?
Yeah, go ahead and sketch it out with me. Okay, so circumcenter perpendicular bisector of each one. So I'm looking for this midpoint. So that would be at 3 here. Midpoint here will be 1, 2, 3, 4. So I'm just drawing like horizontal line, vertical line here. Oh, cool. It actually works out pretty easy. This right here would actually be the center. So that would be at 3, 1, 2, 3, 4. 3, 4. So all I did was draw a perpendicular line from the center point here and the center point here. It landed here, and actually for this point, this is the midpoint. If you were to draw a perpendicular line, it would literally land right there. So that point right there is actually your circumcenter. I'm sure there's a mathematical way to do it, but drawing it's probably going to be your best bet for that. Okay, going on to the next page. Okay, we're just continuing the same thing, same idea at least. Now we're working with some equations. Here it says that ND is 6x minus 2, and E find NF. So we're trying to find this distance here. Let's look at what we got. Looks like we have an angle bisector, and angle bisector. That means that this length is the same length as this, and the same length as this. Okay. It gives us the length of ND and NE, but it gives us an equation. We're going to set these equal to find x since they are the same length. So we're going to start out 6x minus 2 equals 3x plus 7. We get x equals 3, not our final answer. It wants to know the length of NF. Well, they didn't give us an expression for that, but these are the same length. So I can plug 3 into either one of these to find that length. So ND 6 times 3 minus 2, ND equals 16. So therefore NF is also 16, and this is the answer. Okay, so for 12 through 14, we're going to do the same thing. I'm not going to talk through it because it's literally the exact same thing. Just work on them on your paper. You might be working faster than me. That's cool. Let's see, angle bisectors right here. So setting them equal again. Frankie, did you beat me? No. Oh. Did anybody beat me? Okay, so point P is the circumcenter of XYZ. Use the given information to find PZ. So we're trying to find this length right here. Okay, let's look at what we got. This is that weird example that we graphed actually. So with circumcenter, we are working with perpendicular bisectors. So we have one right here. We have one right here. And then for the third one, like the midpoint of this line is right there, and then a perpendicular bisector for that would like be right through that point. So here's the circumcenter here, which is going to be equidistant from all the corners. So this distance will equal this distance, and will also equal this distance. Okay, so we set px equal to py to find x. Get this, and then I just choose one to plug it into. And since px is 32, then pz is also 32, so that's my answer. And then 16, again, with the circumcenter, that means we're working with perpendicular bisectors. So that would be this guy, and this guy. And that means that the distance from that circumcenter to each corner is going to be equal. And my highlighters are dying so fast. Okay, so then we set them equal to solve for x. Does anyone else find solving equations relaxing? Only math brains. And then we got this. And then we just plug that into one of them. Px equals 31. Wants us to find py, which would be the same length, so that would also be 31. And then we are actually not going to do these last few, so that is it. Let me pause this. You're going to do homework on